All right, this is the video where we're looking at resistance. We're actually using this simulation software and going off of this lab sheet called Resistance Lab, which you have in your packet. So I've already created this circuit right here in the simulation software. There it is right there, and I've got my voltmeter ready to go. We can use that if necessary. And the idea is for you to go through the steps of the lab and record your information right here. And so we'll do that together as we go through the lab using the simulation software. So step 2 says measure and record the voltage across the battery and bulb. Measure and record the current in the circuit. Note the bulb's brightness, and we need to write that information right there. So we'll measure the voltage across the battery, and it's 9 volts. And let's actually turn the circuit on, and let's measure the voltage across the light bulb, and it is 4.50 volts. All right, so we want to write that. Voltage of the battery is 9, voltage of the bulb is 4.5. What's the current in the circuit? So we measure the current in the circuit, and it is 0.45 amps. Okay, and note the bulb's brightness. So you've got a kind of a average to low sort of brightness in our bulb here, and that's going to change as we manipulate the conditions of our circuit here. All right, so let's move on. Step number 3 says increase the resistance of the resistor to 20 ohms. Do this by right-clicking on it. So let's go back here. There's our resistor right there. So let's right-click that, change the resistance, highlight 10, and type in 20 instead. Click Enter, and let's look at our circuit now. Some things have changed. Current, bulb brightness, voltage, that sort of thing. So let's move on to step 4. It says remeasure the voltage across the battery and bulb, remeasure the current in the circuit, note the bulb's brightness. All right, so the voltage across the battery, again, it's still 9 volts because that's the energy provided by the battery. The voltage across the light bulb is now 3 volts. And the current in the circuit now is 0.3 amps, and the bulb has actually gotten a lot less bright compared to what it was before. So we can write that in here, or you can write that in there, and then let's go on to question 5 here. Question 5 says, what happens to the voltage of the battery as the resistance in the circuit increases? What happens to the voltage of the battery as the resistance in the circuit increases? Well, the answer is nothing. It was 9 before, and it's still 9 even though we increased the resistance of the resistor in the circuit. Why? Well, we just got to remember that the purpose of the battery is to provide energy to the circuit. So you can increase the resistance in the circuit, but that battery still has that same amount of energy it's always had, and that's not going to change. Question 6, what happens to the voltage and brightness of the bulb as the resistance in the circuit increases? So if you recall, the bulb was brighter before, and it's not as bright as it is now. Remember now, we increased the resistance of the resistor here, and the current also changed as well. Okay, so what happens to the voltage and brightness of the bulb as the resistance and the current increases? The answer, they both decrease. Well, what's the reason? Well, it's because the resistor in the circuit, this guy right here, is slowing the flow of electrons. All right, and that means it's slowing the use of energy by the bulb. All right, so the current's going to go down, the use of the bulb, the use of energy by the bulb is going to go down, and as that happens, as the bulb is using less energy, its output of light is going to go down as a result as well. Okay, because the amount of energy available to the bulb is going to help determine how bright it actually is, because the bulb uses the energy it gets to produce light. So those are some things you can write down for number 6. Number 7, what happens to the current in the circuit as the resistance increases? So again, and let's change the resistance so you can see that again. Let's go back to 10 ohms. Our current is 0.45 amps. Okay, if I go back to 20 ohms, our current goes down to 0.30 amps. So what happens to the current? As the resistance increases, the current goes down. Why? Again, the resistor, what's its job? Its job is to slow the flow of electrons. It pushes back on the flow of electrons, like putting rocks in a riverbed, okay? That's going to slow the flow of water through the river, at least somewhat, okay? And so as you push back on these electrons, trying to keep them to go from here to the light bulb, then our flow of electrons are going to go down. Our current is going to go down, okay? Number 8, increase the voltage of the battery from 9 volts to 15 volts. Do this by right-clicking on the battery. We measure the current in the circuit, okay? Let's go to over here. We're going to change the voltage. Let's highlight 9, and we're going to increase it to 15. Now watch what happens when I press enter. All right. Our current has gone up to 0.5, and the bulb has gotten brighter, and the voltage right here for the bulb has gone up as well. So the voltage of the bulb is now 5 volts. All right, you can see that there. And the current in the circuit is now 0.5 amps. It's gone up. All right, increase the voltage of the battery from 15 to 25. We'll get a little bit more aggressive here, so change that to 25. Again, watch what happens when I click enter. Oh, the current has gone up, the voltage has gone up, a whole bunch of things have gone up. So the voltage of the light bulb is now measured at 8.33, and the current is 0.83 amps. And those are some values that you can put in here. So based on those changes, you can answer question 10. What happens to the current in the circuit as voltage of the power source increases and the resistance stays the same? Well, the voltage, the current in the circuit is going to increase as the voltage of the power source goes up. And you can see that because the current right here is now 0.3 amps. Why does that happen? Explain why. Well, again, the battery provides the push on the electrons to get them through the circuit. So the greater the voltage, the greater the push on the electrons, the greater the force on the electrons to get them flowing through the circuit, and as a result, the current is going to go up. Number 11, what happens to the voltage and brightness of the bulb as the voltage of the power source increases and the resistance stays the same? So we saw that the voltage, which is measured right here on the bottom right-hand corner on the voltmeter, it steadily went up, okay? And the brightness of the bulb also went up, okay? Explain why. Well, remember, the bulb is going to use the energy that's available from the battery. Okay, so as the voltage from the battery here goes up, that provides more energy to the bulb, and the bulb has more energy to produce light. And the more light it produces, the less energy electrons have as they leave the bulb. A lot of energy coming into the bulb from these electrons, and no energy leaving the bulb from these electrons here, because it all gets used up here by the bulb as electrons pass through our filament wire there. So what the battery provides, the light bulb is going to use. So we increase the energy here, we're going to increase the energy output there. All right. Question 12 says, let's reduce the resistance of the circuit to pretty much 0. Do this by removing the light bulb and resistor entirely and connecting the wires back together. This creates a short circuit. So let's right-click, split junction. Right-click, split junction. Let's get this guy out of the way. Click remove. Join those wires back together. Let's right-click, split junction. Right-click, split junction. Sorry. Click the right-click the resistor, remove it, and let's put the wires back together. Bam! Look at the current. It's enormous. The electrons are really zipping through this circuit, and now we got some stuff on fire. Okay, so that is a short circuit. So what happens to the current that has no resistance? Well, the current dramatically increases, things heat up, and you've got a fire hazard, as you can see right here. So you need resistance in a circuit in order for it to be safe. Okay, and we'll see you in future videos.